Good morning, class. So today we are going to start the very interesting topic. This is biomolecules. Very interesting it is, and for class 12th, and it is related with somewhere our daily life, our existence. That means our body is made up of biomolecules, and this is the combination of bio and chemistry. Okay, so let's start with this biomolecules, and that is it is the harmonious and synchronous progress of chemical reaction in our body which leads to life. That means in our body there are lots of chemical reaction occurs in daily basis and even our basis, or you can say that every minute it occurs, and which leads to life, which makes us existing and all that. Okay, so let's start with this. In this we have to start that the first word which comes in our mind when we start this chapter, that is biochemistry. Biochemistry is that, as the name suggests, bio and chemistry. That means chemistry is going to involve in the biological function, whatever the biological activities are there in our body, in our surrounding, whatever, wherever. So in that the chemistry is going to involve, that chemical reaction is going to involve in that. Okay, so the branch of chemistry in which we deal with the life with chemical is known as biochemistry. We are going to deal with the life with the chemicals, and the compound which are used in living cell is all known as biomolecules. All that compound which is which occurs in our living body, in our living cell, that is called biomolecules. As for example, it is like you people have heard carbohydrate, fats, proteins and all that. So what is this? These are the biomolecules. Okay, so one by one we will understand all this thing, what it is. Like example I have written, this is the nucleic acid, and that has a very very important role in our generation to generation changes jo hote hain. That is, it plays a very important role, vital role. Okay, so let's start with the carbohydrate. Carbohydrate is also called the hydrates of carbon. What happens, you understand with this hydrates of carbon, that means carbon along with the water. Okay, so whenever we take out the water, we called it as an anhydride. Yes, but if we add the water, it will be hydrates. So this is carbohydrate. Actually, it is a word which means the hydrate of carbon. And how it is, let me explain you. Carbohydrates, they are naturally occurring biomolecules. Obviously, organic compounds. Why we are saying organic compounds? Because it is made up of carbon, hydrogen, along with the oxygen, phosphorus, nitrogen, and all that are called organic compounds. So, carbohydrate is also made up of carbon, hydrogen, and oxygen. And the general formula is CxH2OY. That means H2O is going to be added with the carbon. That's why it is also called carbohydrates, or that means hydrate of carbon. Example, cane sugar, starch, glycogen, glucose. Among that, I know, I can guess, yes, you people know the formula for this cane sugar, you know the formula for the glucose. Maybe glycogen and starch you don't know, because it is a complex of this thing. Okay, so that I will tell you afterwards. So next thing is, but see, the general formula I have given you, this is CxH2Y, but it is not necessary that all the compounds which have the general formula like this will be considered as carbohydrate. As for example, you see CH3COOH. Okay, so if we write if we write the condensed formula for this, we can write that C2 and this H4O2. So can I take out the common two, like two common, and it will be C2H2O whole twice. So it is coming in form of this CX and H2OY, isn't it? But it is not a carbohydrate. ये carbohydrate नहीं है. So it is not necessary that wherever this formula will be, that will be carbohydrate. But yes, if it is carbohydrate, there must be that must have this formula. Got it? It is not necessary that the one which is having this formula will be carbohydrates, but for sure the carbohydrates will have this formula. Got it? Okay, so now similarly there are some carbohydrates which do not have this general formula but still are called carbohydrates. Some very few are that, and one of that example is ramenose, that is C6H12O5. This is a carbohydrate but it is not having exact like this formula, so this is an exceptional case. Okay, चलिए. Now the carbohydrates can be defined as polyhydroxyaldehyde. What does it mean? Polyhydroxyaldehyde. This means hydroxy group, many hydroxy group will be there. We know that whenever we use more than three, we use the term poly, isn't it? So more than three OH group will be there, and functional group is aldehyde or ketone. Got it? Or the compound which are optically active and on hydrolysis produces same unit. Now what is this? It is very important point, but right now you will not get it. Whenever we will do the structure, then only you will get that how they are optically active compound, and on hydrolysis they produce the same unit. Like if they are carbohydrate, so they will produce the carbohydrate only. On the hydrolysis they will produce the same thing. Got it? Like we will do in next slide. But most common example जो है, that is sugar. We all know, we are very familiar with this, and that is called sucrose. Okay, and in milk there is lactose. And one very very important thing I just want to tell you, that all the carbohydrates, if we see the carbohydrate, their name end with the O's. Is O's. If its name is like whatever the name, if it is ends with O's, it must be carbohydrate. Got it? So like you can say glucose, you can see lactose, maltose, sucrose, ramenose, बहुत सारे हैं, ठीक है? Now this is classification of carbohydrate. That means how we can divide the carbohydrates. What are the ways and what are the basis on which we can classify the carbohydrates? So on that first we will we will classify them on the number of units produced after the hydrolysis. Okay, so carbohydrate when undergoes hydrolysis and it produces whatever the number of unit, on that basis they are divided into three parts, and that is, the first one is monosaccharides. Saccharide word is also used for carbohydrate. Okay, so monosaccharide, that means on it is the simplest form of carbohydrate, and that is not going to be further hydrolyzed. अब उससे ज़्यादा hydrolyze वो नहीं हो पाएगा, और single unit is already the simplest form it is. So the example is glucose, fructose, ribose. Got it? Not maltose, not lactose, because they are in disaccharides. I will tell you. So disaccharides or oligosaccharides also, they are actually there is a little difference in this. If it is disaccharide, that means it will give you two only two, and for the oligo it is mentioned as 3 to 8. Somewhere it though like in some books you will get that altogether 2 to 10. Got it? Simple carbohydrate. But basically if you see disaccharide jo hoga, that will give you the 2, and for oligo we talk about the 3 to 8 in general. Okay, but we don't have to study about any oligosaccharides and polysaccharides. With that monosaccharide and disaccharide we have to understand, we have to know. Example कर लेते हैं, and it is very important point with respect to board exam. So it is for sure one question, like continuously so many times it is asked. Okay, and for that entrance also it can ask. So sucrose, that is going to give you glucose plus fructose. You have to learn this point. ये याद करना must है. It is like you can make a star for that. Okay. So this is the most importantly asked question. Okay, so sucrose on hydrolysis gives glucose and fructose. If you'll see the formula, both have same molecular formula, but their functional group are different. So that's why they are functional isomers, and this is CHO. I will explain all that. This is having CHO functional group and this is having ketone functional group. Okay, खैर वो सब बातें बाद में हम करेंगे. Let's do this. Sucrose on hydrolysis, it gives glucose and fructose. Maltose on hydrolysis gives glucose and glucose. That means it will give you 2 moles of glucose. And lactose on hydrolysis gives glucose and galactose. What is the formula difference and all that we will do later on. Okay, so this is the important point I have told you. अभी तक जितने भी चीजें हैं उनमें एक important point ये point है, so that you have to mark as an important. Now the polysaccharides, if it gives more than 10 unit, okay, on hydrolysis. Example, we can say that cellulose, starch, glycogen, जितने भी ये सब होते हैं, that they are the polysaccharides and they give more than 10 molecules on hydrolysis. Okay. Now, next thing, if we do that classification of carbohydrate, what is this class? Another basis. On what basis we can divide the carbohydrate? So this is on the basis of whether they can reduce or not. Okay, so they can reduce like a CHO group. They can they can be oxidized or not. You can say that they can be oxidized, further oxidized or not. Okay, so if they are going to be oxidized, that means it will act as a reducing agent, isn't it? So like this. So in this way, there are two different types. One is non-reducing sugar and another is called reducing sugar. Non-reducing sugar का मतलब क्या होगा? If the aldehyde or the ketone group are bonded, कैसे bonded होंगे? We will do. So here you have to learn this definition, and this definition is also important. This was like also asked many times. This also asked like by the board exam. Okay, so we can say that if the aldehyde or ketone group are bonded, that means they are not free. We can say in simple way, if the aldehyde or the ketones are not free, then these are known as non-reducing sugar. That means they cannot reduce. They cannot like reduce the other. Got it? So example है all disaccharides like sucrose etc. They cannot reduce the Fehling solution and the tolerance reagent. We have like a test we have done in organic chemistry, that Fehling aldehyde and ketone group, how we will identify that. So there is the test, important test, that is Fehling solution and the tolerance reagent. So all the carbohydrates has the tendency to reduce the Fehling solution and the tolerance reagent. Okay. So, or we can say that in another way, we can say that Fehling solution and tolerance reagent can oxidize the aldehyde. But in this case, since CHO group or ketone group is not free, it is bonded. So there is no effect of Fehling solution and tolerance reagent, and Fehling solution and tolerance reagent cannot oxidize that sugar, that carbohydrate. Got it? So okay. So all that example में आ जाएंगे सारे disaccharides like because उनमें CHO bond जो होता है, जो CHO होता है, that is bonded. So that can be also reducing sugar. Okay, so first was non-reducing sugar and second is reducing sugar. It means that if the aldehyde or ketone group are free, okay, they are not bonded, then these are known as reducing sugar. And examples are all monosaccharides. And in although they are maltose and lactose, they are disaccharide, but they also can reduce the Fehling solution and the tolerance reagent. Okay, so that's why they also come under reducing sugar. One very important question asked from this topic, the slide, that why sucrose is called non-reducing sugar. Okay, so for that it is said that in the sucrose, both the aldehyde and the aldehyde group is bonded. Got it? That means that is not free, and hence they cannot reduce the Fehling solution and the tolerance reagent. That's why sucrose is called non-reducing sugar. Got it? Okay, so let's move to next slide. And this is again like we are going to start the types of. Now we are going to start the monosaccharides and disaccharide only. These two things we have to study. So out of that monosaccharide, they can be of two types. One is called aldose and another is ketones. You can guess what it is going to be. Aldose, that means the functional group will be CHO. The functional group will be CHO. Got it? And in ketones, the functional group will be C double bond O. Clear? So this is the major difference between aldose and ketones. So what are the other difference? Have CHO group already written over here, and have C that I should write two bond. Okay, C double bond O group. So like how to name, how to pronunciate it. Like if carbon is 3, so because carbon is 3, so that's why tri. And as I told you that all the carbohydrate ends with O's, so that can be called triose. Okay, and if they have CHO group as a functional group, then it will be called aldotriose. Got it? And similarly, if the functional group is ketone, then it will be called it will be ketotriose. Got it? Similarly, that pentose and hexose, like this. Out of this one is the most common one, C6, which is called hexose, and aldohexose and ketohexose. These are the important ones. Bio students, they have done this also, pentose ribose sugar, isn't it? So that is C5 and C6 is the main, we can say that the main monosaccharides are that. Got it? Carbon number will be 6, and since their carbohydrates are name and with O's, and aldehyde as a functional group and ketone as a functional group, so that's why aldohexose, and ketone as a functional group, ketohexose. Okay, so let's start with glucose. Glucose, as we know that the general formula, that formula of glucose is C6H12O6. Got it? And if we talk about the empirical formula, its empirical formula is, what will be the empirical formula? Can you tell me? Yes, this is 6 is common. So we can say CH2O. That is the empirical formula, but no issue. Okay, so now it occurs freely in nature as well as combined form, and present in sweet fruits like honey, and sweet fruits like all the jitne bhi sweet fruits hote, it is present in that, and honey also. Monomer of starch, it is a monomer of starch cellulose. Starch, we know that where it is, that is present in the plant. Okay, so structure, it's a structure. If we talk about the which type of a structure it does it belong, so that is aldose and dextrose. Aldose, that means it is it is having aldehyde functional group. Got it? What is this dextrose? You people can understand, you have done in organic chemistry, that is dextrorotatory, isn't it? So from there it comes, this word comes, dextrose. Okay, so I will explain it with the structure only, so just wait for that. Now if we talk about the preparation, how it will be prepared, so it can be prepared by hydrolysis of cane sugar. Cane sugar, that means the formula is C12H22O11. When it undergoes hydrolysis, this will form 2 moles of C6. You can say that C6H12O6, C6H12O6. So you will say that why not I'm writing like 2 C6H12O6, isn't it? But actually it is not. Both the molecules are not of glucose. One is of glucose and another is of fructose. If we'll see the structure of this, it is having CHO functional group and it is having ketone as a functional group. Got it? So that is the difference, and we have we know this thing that aldehyde and ketones are the functional isomer of each other, isn't it? So from there it comes. Another method that is sorry, it's by mistake here. So this is important. Ye jo, we have done that hydrolysis of cane sugar, that is important. Okay, this one is important that you have to learn. Another method is also by hydrolysis of starch. So starch is actually kya hota hai? It is a polymer of glucose, you know. So if we hydrolyze the starch, we will get the n number of moles of glucose. So here C6H10O5, and that is, you'll say that why I'm writing like 10, why not it is 12 and it is 6. So here one H2O molecule is like, whenever we form the bonds now, they glucose molecules, due to this H2O molecule, it's a condensation polymer, type of condensation polymer. That means when 2 moles of glucose or multiple number of glucose, when they combine, so there will be an elimination of a small molecule, that is H2O. So this is the formula of starch. Okay, C6H10O5 whole n, lots of number will be there, it's like countless. Okay, and when n number of moles of water will be added to that, it will give you n moles of glucose only, not fructose, it will be glucose only. Okay, so this is, by this way we can prepare, and this is again going to be a very important part of this carbohydrate or glucose, you can say, reaction of glucose. So it is like a few reactions, and out of that, three are the most important reaction. Whenever it comes in the paper, it comes as a like what we say, as a group, as a question, like तीन number में यही question. Okay, so the first one is when the glucose reacts with HI. Okay, so this is, it forms N-hexane. That means all the what we say, all the OH and CHO molecule will be like will go out, and it will form N-hexane. That सारे OH जो है, it is a type of, what we can say, tell me fast, it is a type of reduction. Got it? So when we HI के साथ हम जब करते हैं और heat करते हैं, तो we know that heat करने पे water molecules will come out. So all that water molecules जहाँ भी possibilities है, it will come out, and it undergoes reduction to form this. ठीक है? So can you say it as a anhydride of this? It's not like that, because see, water we are taking out, but it is not going to change the structure. The structure is of 6 carbon straight chain. Here is it is also. So it is not going to change. If we will take out the one atom, like hydrogen from one carbon atom and OH from another carbon atom, then the structure will change. Something different will be there. But it is not going to change the structure. So that means it is simply a reduction. Got it? Okay. Another is reaction with aqueous Br2. This is important. 3 equation, as I told you, that are important. And out of that, this is first. Okay. And the second one is reaction with Br2, and third one with the reaction of HNO3, nitric acid. So we'll do, if we do with the Br2 act as an oxidizing agent, and it oxidizes the CHO group into COOH. Only this much will change. Rest all will be same. Glucose का जो formula होगा, this all will be same. And this name is called gluconic acid. If you are confused that what is this D and all, don't worry about that. We will do afterwards. Okay, so here you have to understand that glucose will convert into gluconic acid. When it is gluconic acid, when the CHO group of glucose will be oxidized to form COOH, then it is called gluconic acid. And the third important reaction is reaction with nitric acid. So when we react with nitric acid, the CHO, the top one CHO group, and the lower one CH2 group, both oxidizes into COH form. COH, carboxylic acid. And the name of this compound is saccharic acid. Got it? Saccharic acid. In between, it will have 4 OH. All the 4 different carbon will have 4 OH group. And the topmost and the low bottom one will have COH only. Got it? Okay. So these 3 were the important reactions. Other reactions are also there, like another form question, another set of question. It was one set of question. Okay, the 3 question. Another set of question is there. Like this is the again different set of question. It can be asked that how can you prove that glucose is pentahydroxy? Okay, question will be asked how just prove that glucose is pentahydroxy. So for that, what you will do, you have to write this acetylation of glucose with acetic anhydride. It shows this, it has pentahydroxy group. Kaise? Because when we react with this acetylation, when we do this acetylation of glucose in presence of acetic anhydride, it gives pentaacetate. Pentaacetate अगर हम देते हैं तो it quite clear that it is acetic anhydride. That means it is somewhere acid. So if acid is going to convert into here age, ester, isn't it? This is an ester. ये ester है. And this one is a form of acid. Yes. So when the acid gives ester, what is the way? When acid reacts with alcohol, it gives ester, isn't it? So that means it proves that glucose is having OH group. And how many OH group, that we will see afterwards. It gives that 5 hydroxy group. Glucose is having hydroxy group. And since it is giving penta, 5, so that means there must be 5 hydroxy group, isn't it? And we know that at one carbon, more than one OH group is unstable. So to make the structure stable, all the 5 OH group must be on the 5 different carbon, isn't it? Got it? So that is the reason. So here you can write with this with the help of this equation also. This is whenever this question comes, it will be like one or two marker or 3 marker question. So for that you have to write this statement and this equation. Okay, so let me explain this equation. If I'm doing that like acetic anhydride, so this is acetic anhydride structure is like this: CH3. This is C double bond O over here, and this O will be common, and then and this is CH3. Got it? So what will happen when this reacts? So this bond anywhere it can break, like here, suppose that it break. So this will give you H, ye H, and this CH3COOH will go to form CH3COOH. So 5 will be there, and 5 hydrogen from there, 4 from there, 1 from there. It will form 5 CH3COH. And what left? This COCH3 group will be left, that will attach to this. So we can see that CHO यहाँ रह गया, and then COCH3. Got it? So this forms penta-acetyl glucose, and this proves that glucose is having 5 OH group, that also on the different 5 carbons. Got it? Now the next reaction is reaction with NH2OH. We have done in that in that aldehyde ketones, we have done how the aldehyde group reacts with NH2. So this is hydroxyl amine. Okay. So when it reacts with this, it just CHO, this OH group will come out, and this one second, I can write like this: H N HNOH. Yes, can I write like this? So what will happen? This oxygen, which is attached with a double bond, will go with this 2 hydrogen to form water, and this NOH group will attach to this with the double bond. So this is called oxime. When hydroxylamine reacts with the aldehyde, it forms oxime. So since we have that reactant was glucose, so that's why it called glucose oxime. Got it? Okay, another reaction. This is also important, but not so important. It can be asked, and although like already you have done in aldehyde, so there is no such issue. And in this now HCN, you know that reaction. This is very familiar reaction, very famous reaction of this aldehyde group we have done. So when this will, what will happen? This is suppose CHO group. Can I write like this? This is CHO group. So what will happen? This bond, due to this polarity, this bond will split on this side, and due to this, oxygen will have minus sign and carbon will have positive sign, isn't it? This will break H plus and Cn minus. So what next? Addition reaction will be there. Plus will go to minus, minus will go to plus, and this will form O के साथ hydrogen, and this C will attach with the Cn. So this is called cyanohydrin. You know, cyanohydrin. This is the common name of this compound is cyanohydrin. And since we have used the glucose for that, so it is cyanohydrin of glucose hydrin. Got it? So that's it for today. In like next class, we will do the structure of something writing. Yes. So in next class, we will do the structure of glucose, how to draw the structure, what are the other aspects of the structure for that structure. So we will do in next class. Till then, thank you class.